If you own one of these puppies, the BBC Microbit, and you're unfamiliar with the language Python, then you're in the right place. Now, I know it's fairly easy to program this device using those simple languages like Microsoft Block Editor, but I really want to encourage people to try and get to grips with Python, because it really does allow you to do things that you just can't do with these simple drag and drop interfaces. And it's not really that hard. So this is a first lesson in Python. What we're going to do is we're going to create a basic arcade game from scratch. And here's how it goes. So I've loaded up the editor called Moo, which is probably the best way to program in Python. I'll leave a link down below for where you can download this editor. It's very, very simple to use. You just plug the microbit into the USB port on your computer, and there is a button up top, Flash. And once you've programmed something, all you do is you click the Flash button and it uploads it onto the microbit device immediately. It's much easier than using the web interface. Okay, so you can see here in our editor window, it starts with from microbit import asterisk. Every program that you write for the microbit needs this instruction. The asterisk means everything. It's shorthand for everything. From microbit import everything. Now when it says microbit, what it means is the microbit module that is provided as part of the Python language. What that means is you can use instructions like setPixel, which we're going to use in a moment. Now the setPixel instruction is not a native part of the Python language. It's specific to the microbit module, which we are obviously going to use on the microbit. What I'm getting at is you do not need the setPixel instruction if you're programming in Python for a PC, to run your programs on a PC. The setPixel instruction just wouldn't make any sense. So it doesn't make any sense to have that instruction built into the Python language. What you do is you import the microbit module and you get access to special instructions for the microbit, like setPixel and others. I hope that made a kind of sense to you. You don't have to worry about where it pulls the microbit module from. It's all built into Moo. This line here has a hash in front of it and it says write your code here. A hash means that whatever follows the hash doesn't get compiled, doesn't get processed. So whether it's there or not is immaterial. The purpose of the hash is to allow the programmer to put in comments so that he can keep track of what he's writing. So I'm just going to remove that. Without further ado, let's use this setPixel command to try and get a player sprite on the bottom row of the microbit in the center. Here's how it works. Display dot set underscore pixel, open brackets. Now we have to do three parameters inside the bracket. The first parameter is the X value, in other words, which of the 5 LEDs you want to light up horizontally, and they are labeled from 0 to 4 rather than from 1 to 5. So the center one is going to be 2. Then I put a comma in. So now we do the y-axis, which is up and down, and it's the bottom row, so that's going to be 4. Starting at the top, 0, 1, 2, 3, and 4. The third parameter is the brightness of the pixel, 0 being unlit, 9 being fully bright. So we're going to use 9. Let's close the bracket, press enter. So that is now runnable as an actual program, and it should light up the center pixel on the bottom row. So I'm going to hit flash and let's see what happens. Okay, there it is. The center pixel at the bottom is lit up as expected. But the thing is, I want to be able to press the A button and the B button to move the sprite left and right. So I need to make use of what's called a variable. What I'm really saying is the X position of the player sprite will vary. So whatever varies needs a variable. So I'm going to add a couple of lines in to give myself some space. I'm going to set the initial value of the player's X position to 2. So I need to make up a variable name. I could call it anything, but I'll call it something logical. Player underscore X equals 2. That's the starting value that I'm choosing of the player position. So within this set pixel instruction, I'm going to change the 2, because the 2 will vary as the game goes on, to player underscore X. There we go. All right. So let's flash that again. It should do exactly the same thing as it did before, but I'm just doing it to make sure that there are no errors. And there we go. We've still got our pixel on the bottom lit up. Now I want to be able to press the A button to move that character, to move that sprite left. And we use an if instruction to do that. So in plain English it would be, if the user pressed the A button, take 1 away from the value of player X. So if it was 4, it would become 3. If it was 3, it would become 2. If it was 2, it would become 1, and so on. So here's how that translates into actual Python code. If button underscore A dot was underscore pressed, and then we have to open a bracket and close a bracket, then we put a colon. Now I know these brackets and underscores and dots are all a little bit confusing, but if you think of button underscore A as an entity, the dot is a separator, and then was pressed is another entity. Just like above, it's display as an entity, and then the dot separates that out, and set pixel is an entity. So these periods, these full stops, they become clear to you when you start to understand that display is a category of instructions, and set pixel is an instruction within that. There's other instructions like display.clear, which we're going to use. So that's how it's all grouped together. Display is like the outer category, set pixel is one of the many instructions within that category. It's the same with button A. Button A dot was pressed, button A dot is pressed. There's different things you can do with button A. Every if instruction has a condition followed by a colon. The colon indicates that we're now moving out of the condition. And then the thing that we want to execute must be indented by 4 spaces. I want to take 1 away from player X. So that is written as player X minus equals 1. That's the Python shorthand for player X equals player X minus 1. It can be shortened to player X minus equals 1. Now we want to do the same for button B. You've got to come back those 4 spaces. If you don't, that means that this if instruction is part of the consequences of the previous if instruction. We've got to go back. Some languages have end if to signify when an if instruction ends. Python knows what to do as long as you keep your indentation correct. Button B was pressed. Again, these brackets that you're seeing, open bracket, close bracket, what's the point in that, you might ask? I don't want to get too heavily into why those things are there. They just have to be there. There is a reason for it. It's to do with functions and how they work, but I won't get into too much of an explanation about that right now. So this is when you press the B button, and we want to add 1 to the value of player X, so that's plus equals 1. Now, this should work if I compile it now, but unfortunately the computer doesn't know that I want this to loop around and round. It will simply execute these instructions, get to the bottom of line 9, and then simply end the program. So if I run this now, nothing will happen. I can press the buttons all I want, but they won't do anything because the program has ended. I need some way of sending this into a loop so that the microbit is continually scanning for new input from the user. And here's how I do it. The most basic loop that you can do is a while true loop, and I'm going to put that above at line 5. While space true. Now notice true has a capital T. It has that because it's not a variable called true. It's a special term. That's why it has a capital. And just like an if instruction requires indents, so does the while true instruction. So I'm going to indent everything, preserving the original indents, but moving everything along 4 spaces. So in other words, that means lines 6 to 10 are all part of the while true loop. And if I put something in line 11 here, and I indent it right at the beginning, that means that I'm outside the loop again. Okay, but we're not going to do that right now. We're going to test our code. Now there's going to be some problems with it, I know that already, but we'll tackle them one at a time. Let's flash this onto the microbit and see what happens. Let's see if I have movement on the B button. I do. I do indeed. Have I got movement on A? But you see what's happening? It's drawing the, it's moving the character along, but it's not undrawing the sprite from the previous location. Also, another problem that's going to happen is that I can also go off the screen, and that will cause an error, like you see. So line 6, value error. Basically, it means I can't display the sprite on pixel -1 because there's no such pixel, right? There's no such LED. So let's tackle those 2 problems. The first one is fairly simple. I need to undraw the sprite, and I'm going to do it in a very quick way. I'm simply going to clear the screen before I display the sprite, and I can do that with display.clear and open bracket, close bracket. That will simply wipe any lit LEDs. So it clears it, it displays the player, it waits for input, and then it loops back around, clears it again, and so on for infinity, constantly waiting for player input. Now let's also fix the problem of the fact that you can go off the screen and crash the microbit. I need an extra condition in both of these if statements that says if button A was pressed and the player is not in the leftmost column, then move the player to the left. So we can use and to add an additional condition in here. And the value of player X is greater than 0. That will do it. That means if button A was pressed and player X was greater than 0, meaning that the player X was in 1, 2, 3, 4 or 5, then take 1 away from it. And again, I'm going to do the same for the right hand side, and player X is less than 4. That should do the trick. That will stop the player from moving too far off the right hand side. Let's flash it and see what happens. Okay, it's working. But what happens when I move too far? Nothing. It stays on the screen. So it's doing exactly what I wanted it to do. So there is our player sprite complete. Now we want another sprite. I'd like an enemy that appears along the top in a random LED and starts falling down the screen, and the player's task is to avoid it, right? So we're going to need a couple more variables. Why? Because the enemy is going to change position as we play the game. The enemy can start in any one of 5 LEDs and can also, as the game progresses, move down through any of these 5 LEDs vertically. So we're going to need a variable that we'll call enemy X and enemy Y. And I'll set those up top where I set the starting value for the player variable. So we'll call it enemy X. This is a tricky one. I can't just put 2 because I want it to be in a random position. So here's how we get a random value into enemy X. Random dot rand int brackets starting value of the random range, which will be 0, last part of the random range, which will be 4. So that says set the value of enemy X to any random integer, that means random whole number, between 0 and 4 inclusive. The starting position of enemy Y, that's a simpler one. It's going to be the top row, row 0. So I just set it to 0. All right. And that's not going to do anything until I actually display the enemy on the screen. So to keep things orderly in our code, I'm going to display that at exactly the same position in the code where I'm displaying the player sprite. That makes sense. So display set pixel brackets enemy X comma enemy Y comma, and I'll just make it full brightness again, 9. So you know we don't actually need a player Y variable because the player is always in row number 4. So, but we do need one for an enemy because the enemy will float down the screen. So that should get the enemy displayed. Let's test our code once again. Flash. Uh-oh, I made a mistake. Line 4, name error. I know what I've done. This function random.randint is not a native part of Python. Just like the instruction display.setPixel is not a native part of Python. In order to make Python understand that, I have to include it up here. I have to include the module or the library for it. And I do that with import random, just like I did from microbit import everything. Import random will import the random number functions. There are more of them than just randint. So it will work now. Let's flash it again. There we go. We have our sprite appearing at the top of the screen. Now if I reset the microbit, it should rerun the code again without me having to reflash it, and it should hopefully pick a different random value. Oh, it happened to pick the same one. Let's try it again. There we go. I'll keep resetting it, and you can see each time we're getting a completely random value for the starting position of the enemy. So far so good. So let's now get the enemy moving down the screen. Lines 12 through to 15 at the bottom, the last 4 lines, they're the pieces of code that handle the player movement. So it makes sense to do the enemy movement around the same sort of place in the listing, in the script. So I'll do it below. And all I really want to do is add 1 to the value of enemy Y. Enemy Y plus equals 1. Now, I know I'm going to encounter a problem if I flash this because it won't know when to stop. It will just, on the first pass through the while true loop, enemy Y will go from 0 to 1. On the next pass, it will go from 1 to 2, then from 2 to 3, and so on. And eventually we'll be getting values like 5, 6, 7, and 8. And that's just going to crash the microbit again because you can't display the enemy sprite on pixels 5, 6, 7, and 8. They just don't exist. So I need to put a little bit of validation in here that says basically if the enemy goes past the bottom of the screen, reset the enemy to the top of the screen. So a simple if statement should suffice. If enemy underscore Y is greater than 4, bear in mind that 4 is the bottom row. If it's greater than 4, remember my colon, then set it back to 0. Enemy Y equals 0. All right, let's flash that. Now that's an interesting effect we've got at the moment. First, let's break down the problems that we have. The first problem is the enemy is moving far too fast. So let's fix that one immediately. I can add a sleep instruction to slow him down. So sleep, open brackets, let's do it about let's say a quarter of a second for every pass through. So it means every time we go through the while true loop, there will be a pause of a quarter of a second, 250 milliseconds. So let's flash that. That's much better. So the next part of the problem is that when the enemy goes back to the top of the screen, it doesn't set a new value for its horizontal X position. So I'm going to have to do that as well. So that will be another consequence of the enemy going off the bottom of the screen. So I want to do that at the same place. So when I set enemy Y to 0, I also need to set enemy X to a new random value. So it's random.randint brackets 0, 4. Let's flash it this time, and I think we should have complete success. There you go. The enemy is behaving as expected, crawling down the screen one at a time, but you will notice that there's no collision detection yet. When the enemy hits the player, as you just saw, nothing happens because we haven't programmed anything to happen. So that's what we're going to do now. Now you might think that we should just put that right at the bottom of the screen as the next instruction in the sequence, but not really. We have to sort of think carefully about where to position this. Basically, I'm going to put a piece of logic in that says if the enemy and the player are in the same place, end the game. The reason why I don't want to put it at the bottom is because, well, I'll explain it as we go. I'm going to put it in here at this spot. I'm going to put it in other words, right after the display has been refreshed. And here's the logic. If the enemy, we've got to do it in two different steps. If the enemy Y, first of all, equals 4, what that means is if the enemy is on the bottom row, which is the row the player is on, and enemy X is equal to player X. Notice the double equals. This is because we're doing something different from what we were doing up in line 4 when we were declaring the start value of a variable. We are asking the question, is the part on the left equal to the part on the right? That's why it's a double equals. It's a single equals when you're saying set the thing on the left equal to the thing on the right. So hopefully that clears up that confusion. Okay, can you follow the logic? It's two conditions, both separated by an and statement. If the enemy Y is in the bottom row and the enemy X is on the same position as the player, we can't just do enemy X equals player X, because that would mean that the computer would detect a collision no matter what row. I mean, in other words, the collision would happen even at the top of the screen. So we have to do the X and the Y. We have to be very precise. We want to end the game at that point. In other words, we want to come out of this while true loop, and we do that with a simple instruction called break. That will end the loop and send the processor down to the bottom here, where it will continue on with what happens next. So I basically want a simple game over message to come up on the screen. So I will use another instruction in the display category called scroll. Open bracket, open quote, game over, close quote, close bracket. That's how it's done. That will scroll the words game over on the screen. Now the reason why I put this piece of logic for the collision between the enemy and the player, the reason why I put it there and not at the bottom is because here in lines 9 to 11 we are refreshing the display. In other words, we are showing the player exactly where things stand. Now the first thing you need to do after that, before you allow any movement of either the player or the enemy, is to basically check what are the consequences of the player and the enemy being in the positions that they are in. If those consequences are that they're in the same spot, end the game. You need to do that before you do any movement of the player or the enemy, because what this section at the bottom will do is it will change the values of where the player and the enemy reside, but it will not refresh that information on the screen until it loops back around and does it here. So in other words, the values would change, and then the collision would end up relating to something that isn't on the screen. In other words, you'd kind of be colliding with a ghost, as it were. You'd be colliding with the position that the enemy is in, but it hasn't showed you it's going to be in that position yet. Yeah, I'm getting a little technical, I know. But if you just try to follow the logic with your mind, you'll kind of see that it makes sense. So the main game loop contains a display section, a consequences section, and a movement section. And if you stick to that sort of logic, you can get pretty much any arcade game working. So let's test this. Let's see if it works. Flash. It is a rather easy arcade game, I have to say. So maybe I'll just move over and get myself killed. There we go. It does work. So there you go. That is an introductory lesson to the Python language. I personally have got really into it, so much so that I wrote a book about it, which I'm going to show you now. The book is called Microgames, Python Tutorials for the BBC Microbit, and it contains 12 game making projects, and it's available as an ebook formatted in A4 so that it's easy for you to print if desired. Instructions for how to buy this are in the description below. It can be bought directly from me through PayPal, and I'm also selling copies on eBay if anyone's interested. So hope you enjoyed this little tutorial. Take care, folks. Bye.